In this section, we talk about relation and function, and then we're going to evaluating some functions. All right, relation is any set of order pair x, y, where all the x value make up the domain and all the y values make up the range. That's all it is. So it is as a set of order pair x, y. X value make up the domain, y value make up the range. Right, so for example, I have this set here, right, where x will be 1, 2, 5, pi, right? Those are my x. Maybe I'll highlight the x in blue here. And then my y will be the second component, right? 3, 4, 6, and e, right? By the way, e is just another transcendental number. If you're in finance, you should be familiar with e by now. So domain is 1, 2, 5, pi. If the elements are repeated, do not write twice. Range, you write red. Range is going to be 3, 4, 6, and e. Make it a little bit darker here. Okay, now function. Function is a relation, meaning it's still an order pair x, y. Let me highlight here. Is a relation, meaning that's what it's saying. It's still an order pair x, y. The only thing difference that in function, assign to each element in this domain exactly one element in range. What this sentence saying is that x cannot be repeated. That's all I'm saying. Cannot be repeated. For every x, only one y. Right. Now, y can be repeated. That's fine to have 2 or 3 y's. But x cannot be repeated. So x, here, you often hear that x is independent variable. Very independent variable. In statistics, we don't say this a lot, but in math people, they say this quite often. Y is dependent variable. Y is a function of x, right? Now let's take a look at these two examples here. Can you tell me, is it a function or not? Remember, function is a relation, meaning it is a order pair xy, which these two problems represent. But in order to be a function, x cannot be repeated. So let's see. It looks like this one right here. It looks like it is a function, right? I don't see any repeated x. Right, so yes, it is a function. Right. What about this one? No, there's repeated x here. There's repeated x here. Repeated x there. Bad news. You say repeated x. Not a function. Use red. Not a function. Okay. All right. That's all it is. So remember, function is an order pair xy where x cannot be repeated. That's all. Let's evaluate some function. Given f of x equal x squared plus 2x minus 3, they want you to replace some value for x. Right. So for example, part A here, they want you to evaluate f of -3, meaning everywhere I see x, I replace x with -3. If I was you, I'll do this. Everywhere I see an x or a variable, I use parentheses. The reason I do this because sometimes when you have like a lot of negatives, you don't make mistake easily. So -3 here, -3 here for x. And now you evaluate. So I have -3 quantity squared, that's +9, right? -6 minus 3. So that will give me 0. I wanna point out something here. Don't write this down. A lot of people do this when they don't get when they don't do that parenthesis thing I just said. They do this -3 squared plus 2 times -3 minus 3, and then -3 squared without the parenthesis, that's -9. So you see how your answer can be very different, can be different. That's what I meant by using the parenthesis. All right, f of 2x. So basically everywhere I see x, I replace with 2x. That's all. 2x, 2x. So I got 4x squared plus 4x minus 3. And that will be my answer. You don't have to factor it. They didn't say anything about factoring. Same thing here. Minus 3. And this time it's going to be negative x. Negative x. Easy peasy, because we have the parenthesis thing. Negative x quantity squared is x squared, okay, minus 2x minus 3. Again, don't bother to simplify. Us 2. And last one, I'll go down here. Replace x with x minus 2. This time you make the parenthesis a little bit fatter. X minus 2, x minus 2. X minus 2 quantity square. You can write out twice. X minus 2, x minus time x minus 2. So give me x squared minus 4x plus 4. Distribute these two. So plus 2x minus 4 minus 3. Let's combine some term. I have x squared minus 2x minus 3. And that'll be my answer. Right? You combine this one with this one, right? And this with this with this. All right, and that's it for this part.